monetary word problems, or word problems involving money. I want to start out by doing a fairly simple example. A piggy bank consists of 10 quarters, 6 dimes, and 5 nickels. How much money is in the piggy bank? Well, this is a fairly easy problem. We could quickly figure this out, but I want to establish a formula for these problems because the problems are going to get much more difficult than this. So this is the formula that we're going to use. Value of money times number of units of money equals total value. For example, in our example here, we have 10 quarters. The value of a quarter is 25 cents times the number of quarters, which is 10, and that, of course, gives us $2.50. So this is the formula that we're going to use. Let's go ahead and figure out how much money is in this piggy bank. There's 5 nickels. The value of a nickel is 0.05 cents. There's 5 nickels. So we get, what's that, 25 cents. There are also dimes. There are 6 dimes, and the value of a dime is 0.10. And we can just add all that together and get $3.35. Okay, so this is the formula that we're going to use throughout this lecture. Now let's do a typical problem that you might find in an algebra book. Okay, Wendy has a purse consisting of quarters, dimes, and pennies totaling $3.77. She has 6 fewer dimes than quarters and 5 more pennies than quarters. How much of each are in her purse? A lot going on here, a lot tougher than the piggy bank problem. So what we need to figure out is what is going to be our variable throughout this problem. Well, I'm going to just write a note to myself that I have quarters, dimes, and pennies. Now I'm going to try to come up with a variable that describes my quarters, describes my dimes, and describes my pennies. Now remember, throughout all of these word problems, we have to come up with one variable that's going to work with each of these components. So let's try to read the problem again. Wendy has a purse consisting of quarters, dimes, and pennies. She has 6 fewer dimes than quarters. Well, if we let Q equal number of quarters, then how many dimes does she have? Well, she's got 6 fewer dimes than quarters. So the number of dimes is going to be the number of quarters minus 6. Similar, let's look at the pennies. She has 5 more pennies than quarters. Well, this is the number of quarters, and the number of pennies is Q plus 5. So we've got Q quarters, Q minus 6 dimes, and Q plus 5 pennies, which is fabulous because we have one variable describing each component of our problem. Now, let's go back to our equation that we're going to use. Value of money times number of units equals total value. Well, we've got Q quarters. The value of a quarter is 0.25. So we have 0.25, that's the value of a quarter, plus, well, we have dimes. The value of a dime is 0.10 times the number of dimes. The value of a penny is 0.01 times the number of pennies. And that, of course, is equal to the total, which is 377. Now that is a linear equation. All our variables have the power of 1. And it's a decimal linear equation. Again, if you're not familiar with solving decimal linear equations, take a look at the decimal linear equation lecture, and we'll get you caught up to speed. So let's try to solve this equation. Remember, to get rid of the decimal, we have to multiply by the appropriate power of 10. In this case, we're going to have to multiply by 100 to move every decimal 2 places, so I'll do that. Multiplying by 100 here gives me 25q. Multiplying by 100 here gives me 10. Multiplying by 100 here moves the decimal 2 places, so I just get 1 equals multiplying by 100 here, 377. Now I have a much easier linear equation because my decimals are gone. Now let's just distribute, combine like terms, and try to solve. So 25q plus 10q, I'm distributing, plus 1q plus 5 equals 377. Let's combine like terms. 25q plus 10q is 35, plus 1 more is 36q. Negative 60 and a positive 5 is negative 55. With each step, the linear equation becomes easier and easier for us. Let's move the 55 over because we want the q's on one side of the equation. That's gone. 36q is equal to, let's see, that's 432. And now to solve for q, we divide both sides by 36. So we think q is equal to 12. Now, did that solve the problem? Are we done? Let's take a look at the original problem. In the original problem, we were asked to solve for how many of each meaning how many quarters, how many dimes, and how many pennies. Well, remember, we said that there were 12 quarters because q is equal to 12. If q is equal to 12, then q minus 6 is equal to 6, which means there are 6 dimes. If q is 12, that would mean we have 17 pennies. Now let's just check and make sure. Now how can we check? Well, we know that the total is $3.77, so let's see if this adds up to $3.77. Well, 12 quarters. 12 times 0.25, what's that? 12 quarters would be $3. 6 dimes, so that's pretty easy. 6 times 0.10, that's 60 cents. And 17 pennies is 17 cents. And notice it adds up to the desired $3.77. So that's how we attack monetary word problems. Try to get a variable that describes each component and then assign value to your variables. And then you get a fairly easy linear equation involving decimals.